Okay, so the first question says identify the coordinates of any local and absolute extreme points and points of inflection. And I believe this is the only one that asks about points of inflection. So that means you have to do the first and the second derivative. So this one's a little bit long. But I took the first derivative. So move the 4 to the front, down one on my power. And then I set it equal to 0. So I actually factored out 24x squared to make it a little bit easier to see. And so I got x equals 0 and negative 4. When I set those when I put those on my chart, so I have my first derivative chart, I put negative 4 and 0, and then I plugged in test points like negative 5, negative 1, and 1 to see what was going on. And I got negative, positive, positive, which means negative 4 is a minimum. To find the y value, plug it back into the original. So I got negative 512. No change here means that 0 is probably a point of inflection. I wrote that after I took the second derivative. So I took the second derivative. I factored out a 24x this time. And so I set those two factors equal to 0. And I got 0 again. There is a change in concavity for both of these, negative 8/3 and 0. Plug negative 8/3 back in, and that will give you the y value. I don't know why I didn't write it down yesterday, but we did that in class. So I have points of inflection, 2 points of inflection, and 1 minimum. And so I put that back over here. I don't think negative 8/3 is 0. Oh, that's okay. That's okay. Never mind. Got it. There it is, because it was a gross number. There's when I plugged in negative 8/3. So there's my minimum and my 2 points of inflection. I stated where it was increasing, intervals for increasing because my derivative is positive, interval for decreasing because my derivative is negative, concave up because my second derivative is positive, concave down because my second derivative is negative. All right, number 2. It also asks to graph the function. You can graph it and check it on Desmos if you want to. I'm going to ask you to sketch it. Number 2, use a given function in a given interval to complete parts A and B. So part A says determine the absolute extreme values of f on the given interval when they exist. So they gave us an interval. So not only do we have to take the derivative and check those points, but we also have to check our endpoints. So I took the derivative, set it equal to 0. It should be equal 0. So I set all of these equal to 0. Negative 6 equals 0 is nothing. X minus 5 equals 0 gives me 5. X minus 1 equals 0 gives me 1. I plug in 1 and 5. I also plug in my endpoints and see which one's the highest and which one's the lowest. I don't have to make a chart. Number 3 said, part B said, confirm your conclusions with a graphing utility. We don't need to do that. Find critical points, domain endpoints, and extreme values. They didn't give me a domain, so I don't have to worry about that. They didn't give me something with domain restrictions, so I don't have to worry about that. And they want absolute and local extreme values. So I took the first derivative and set it equal to 0. So when I took this derivative, I don't really like these fractional exponents. So I factored out an x to the negative 1/3 because it can be gross over here by itself. I also factored out a 2/3 because there was a 2/3 here, and then I can factor out a 2/3 there. So when I factor out a 2/3, that left me a 4 because 4 times 2/3 is 8/3. And then I just took out that 2/3, that left me a 5. When I factor out x to the negative 1/3, when you multiply like bases, you add your exponents. And so when I factor something out, that's dividing. So I actually subtract my exponents. So I subtracted a negative 1/3, which meant add 1/3. So 5/3 plus 1/3 is 6/3. And 6/3 reduces to 2, so that made it nice. And I just took out this whole thing, so that just left me with 5 there, which made it nice also. So I set this equal to 0, and I got plus or minus square root of 5 over 2, which you could put on your calculator. I just didn't because I didn't want to waste time. I moved this to the bottom of the fraction, so I want where this is, my first derivative is undefined, so that's at 0. So I set up my chart. I know that -4 is smaller than this. Square root of 5 is a little bit bigger than 2. So I just chose something that was smaller than -1, like -4. And I tested -1, I tested 1, I tested 4. So when I plug those back into this, I got a negative number, positive number, negative number, positive number. I also put on my chart what was going on at these critical points. So I got 0, undefined, and 0. Then I have a min, max, min, because it go from decreasing to increasing, increasing to decreasing, decreasing to increasing. So that's where I was testing it. So I just made a list off of my chart, decreasing on these two intervals because my derivative is negative, increasing because my derivative is positive. I had a max at 0, 0 because my derivative goes, my function goes from increasing to decreasing. My derivative goes from positive to negative. So my derivative on this one goes from negative to positive. All right. So these were absolute mins. You could graph it and check it, but these were absolute mins, lowest points on the graph. Okay. I skipped number 4. I'll go back and do number 4. Number 5, ask for the derivative, where the derivative is equal to the slope of a secant line. So it says f of b minus f of a over b minus a, which is slope of a secant line, equals f prime of c. So that's the derivative of, or that's the slope of the tangent line, which would be the derivative. They want us to find the x value where those are equal. So they gave us over the interval from -1 to 1 for this function. So this is x1 and this is x2. So I took those values, plugged them back into this function and got the y values. Then I did change in y over change in x, or the slope of the secant line. So that gave me 3. Then I took the derivative of f and set it equal to the slope of the secant line. And then I moved the 3 over and I factored. So I did, so there's 2 different ways to do this. You can do AC method, multiply 3 times -1. I renamed the middle term and factored. You can also slide and divide, which means you take your factors and divide by what you multiplied by here. Doesn't really matter either way. Then I set these factors equal to 0, and I got 1 and -1/3. So those are the values. When x is 1 and when x is -1/3, I have a tangent line to the graph that has the same slope as 3. All right, number 6 has 3 questions. The 3 questions are, so it gives me this function, find the velocity when t is 2, find the maximum height when it occurs, and then find the velocity when the height is 0, or when s equals 0. So I took the derivative and plugged in 2, and I got 48 feet per second. I used the derivative and set it equal to 0 because I know max height means maximum on the graph, and that's where my derivative is 0. So I got 3.5 seconds. I went back to the original and plugged in 3.5 seconds to find the height, and I got 280 feet at 3.5 seconds. And then for the last part of that, find the velocity when the height is 0. So I plugged in 0 to the original function for the height, and I found the time. One of the times was negative, so I kicked it out. Literally graphed this. Okay, I'm not wasting time doing quadratic formula. I graphed it. I pulled the 2 times because that's what I need to plug into the derivative. Plugged into the derivative, and I got -133. We'll call it -133.9. So this object was decreasing at a rate of 133.9 feet per second at 7.7 seconds. Number 7, determine all the critical points for the function. So we were also supposed to find where the function is increasing and decreasing, and identify local and absolute extrema. This is actually a 4th degree function, so we are going to have some absolute mins because it opens up. So I took the derivative. I did product rule and chain rule. First times derivative of the second, derivative of the inside is 1, and then second times derivative of the first. I factored out an x minus 17 squared from both of these terms, this term and this term. And so when I factor out this factor, that leaves me x minus 1 times 3, and that left me one of those factors. So I'm combining these, so 3x minus 3 and x minus 17, so that left me 4x minus 20. I set each of those factors equal to 0. I got 17 and 5. I made my chart. I plugged in test points, -4, 6, and 20. I don't know. You pick your own numbers. Then I got negative, positive, positive. So I know 5 is a minimum. I plugged 5 back into the original, and I got this value. And that also helped me when I graphed it on Desmos to reset my range so that I could actually see everything. I didn't have to scroll. Point of inflection, I'm assuming right now this is a point of inflection because I didn't have it change, increasing, decreasing. I took the second derivative from this, and then I factored out a 4 this time because there's a 4 here and a 4 in that, just to make it easier on myself. I factored out an x minus 17, so that left me with this. I set this equal to 0. I set the second derivative equal to 0, and I got 17 and 11. I put those on my chart, and they're actually 2 points of inflection. So there's a point of inflection, and so plug these back into the original to get the y's. 17, 0, and 11, negative 2,160. And so I just made my list. This is an absolute min, and it's increasing where the derivative is positive, decreasing where it's negative. And then I have concave up and down where my second derivative is positive, it's concave up, or my second derivative is negative, it's concave down. All right, so I'll do the trig one and redo it or add another video.